Our planet has endured for billions of years amidst significant catastrophic events that shaped the world we currently inhabit. However, the inevitability of a devastating and potentially lethal event looms over the Earth. This future event could signify the end of the experiment called humanity. There are countless scenarios our planet may face, given past events such as the breakup of Pangaea or the meteor impact that wiped out the dinosaurs, demonstrating Earth's resilience in the face of such apocalyptic events. These events transformed the geography of our planet and gave rise to new eras for the life forms that followed. Unfortunately, these changes often come at the expense of creatures already inhabiting the Earth, so we too could be the target of a possible extinction. However, the future holds the possibility of an even more devastating extinction event than our mere mortality. This event would not only threaten humanity but also the very existence of planet Earth. In a grim scenario, the world as we know it could eventually be reduced to dust. But the question that remains is what would be necessary to trigger such destruction. The top hyperkin hurricane, wherever they occur, hurricanes remain one of the deadliest natural events on our planet, leaving a trail of tragedies wherever they pass. Imagine then if an asteroid were to strike one of our oceans with extraordinary force and heat. Hurricanes would seem insignificant in the face of such a collision. A colossal asteroid could superheat the oceans to over 49 degrees Celsius, unleashing a massive storm known as a hyperkin hurricane. These events would move as quickly as the speed of sound, and clouds would reach heights of up to 40 kilometers. Winds would hurl water and aerosols into the stratosphere, destroying the ozone layer. Even if the winds didn't transport you into space, the radiation on the Earth's surface could fry you. Hyperkin is the name scientists have given to the largest hurricane that could exist on Earth, surpassing the Category 5, which indicates the maximum rating magnitude of a hurricane on the Saffir-Simpson scale. It has never happened, but its existence cannot be ruled out. However, for this to occur, we would need to be facing very precise conditions. Theory suggests that if such conditions existed, the hyperkin could be generated, and we would not be prepared for it. The hyperkin is a megahurricane with winds of 800 kilometers per hour, a speed very close to the speed of sound at 1,235 kilometers per hour. To put it in perspective, we would have the same winds in a downdraft as those emitted by an atomic bomb near its detonation site. These continuous winds would destroy everything in their path with a level of ferocity never before seen. It may seem like a very remote possibility to contemplate, and indeed it is, but there are a series of perfectly viable conditions that could occur. Factors and causes behind this super hurricane's birth could include a combination of surface temperatures in the seas reaching 48 degrees Celsius. It would have to be exceptionally hot on our planet for the seas and oceans to reach these temperatures. Only with a massive volcano erupting on the seafloor could the water heat up to such levels, which could be one of the reasons for these ideal temperatures for hyperkin formation. A gradual and continuous warming of the waters due to climate change could also lead to the formation of this colossal hurricane. Although the highest temperatures recorded in the waters to date are 35 degrees Celsius, continuous warming could lead to this dangerous consequence. The warmer the ocean waters become, the greater the possibility of hurricanes existing. Another scenario would be heating caused by the impact of a large meteorite in the waters. This is another possibility that could cause a temperature increase, although this possibility is more remote. What is recorded is a supervolcano that erupted in subaquatic waters around 250 million years ago. During this era, many existing species were exterminated. Number 2, Jupiter turning into a giant superstar. Jupiter, the gas giant, possesses twice the mass of all the planets in our solar system combined. Furthermore, the gases swirling within Jupiter's atmosphere are composed of the same material as the Sun. Therefore, if Jupiter were to become even more massive, what could happen with such mass and gases in its atmosphere? Jupiter would transform into a star, which, positioned in the middle of the solar system, could induce changes in the orbits of planetary bodies. Consequently, Earth could also end up being pulled closer to this blazing superstar, exposing it to the heat of this new celestial body. It could lead to the planet being burned due to the high temperatures of the former planet. An even graver consequence would be gravitational forces transforming our world into a rogue planet, meaning Earth could be sent to a new region of space outside the solar system, and we could wander endlessly through the universe in search of a new home without the sun's warmth to keep us heated. As a result of this intergalactic journey, Earth's surface would freeze, resulting in the extinction of all life on our planet. However, perhaps it is wiser to concentrate our attention on the star we already have instead of speculating about those that have not yet formed. After all these possibilities highlight the fragility of our existence in the face of cosmic events. Number 3. The Sun engulfing Earth. This ball of gas is responsible for making life possible on our planet. However, as the Sun burns 600 million tons of hydrogen every second, it's only a matter of time until this energy source is depleted. When this happens, the Sun's core will become saturated with helium and start to shrink. The increase in pressure and temperature would cause the Sun to emit vast amounts of energy, and its outer layers could expand, creating a deadly heat wave on planet Earth. Our oceans would evaporate into thin air, and the radiation would scorch the planet's surface until finally, the Sun, the central star of our solar system and giver of life to our planet, would engulf our sterilized structure of life. If the Sun continues to expand, our solar system may face a new threat. If the Sun gains even more mass before collapsing, we might witness the birth of one of the most mysterious phenomena in the universe, a black hole originating from a dying star. The gravitational attraction of this void could destroy other stars and planets. Currently, the Sun is too small to create one of these catastrophes. However, if a black hole were to appear in front of Earth, the uneven gravitational attraction would begin to deform the planet, causing earthquakes and other catastrophic events. There are studies suggesting that in 5 billion years, the hydrogen fuel in the Sun may be depleted, which could lead it to expand and become a red giant. In the process, the central star of our solar system could engulf planets like Mercury and Venus, as well as our own planet Earth. Although the dynamics and possible outcomes of the phenomenon called planetary engulfment are poorly understood, it is believed to be a relatively common fate for planetary systems. Details of the process were published in a study conducted by scientists at the University of California, USA, released in the Astrophysical Journal in June 2022. To reach this result, the researchers conducted hydrodynamic simulations that help explain how forces act on a planet when it is engulfed by an expanding star. A note published by the University of California explains that the results show that interactions of a substar body with the hot gas in the outer envelope of a star like the Sun can lead to a series of outcomes. This depends heavily on the size of the object being engulfed and the stage of evolution of the star. The scientists pointed out that there is a vast variety of planetary systems that have already been identified by exoplanet search programs. As these systems evolve, a significant portion of them could suffer from planetary engulfment, as explained by the Institute. The study may help elucidate recent observations of planets and brown dwarfs orbiting stellar remnants, such as white dwarfs and subdwarfs. Other research on the topic has already been conducted and suggests that these types of systems may precisely be the result of planetary engulfment, involving the shrinking of the orbit of the engulfed body and the ejection of the outer layers of the star. According to Ricardo Yarza, the lead author of the study, a graduate student in astronomy and astrophysics at the University of California, Santa Cruz, evolved stars can be hundreds or even thousands of times larger than their planets. This disparity in scales makes it difficult to conduct simulations that accurately model the physical processes occurring at each scale. Yarza explains that as the planet travels within the star, drag forces transfer energy from the planet to the star, and the stellar envelope may detach if the transferred energy exceeds its binding energy. Normally, stellar envelopes are formed from dense stellar wind or may be present before the star's formation. The stellar envelopes of old stars eventually evolve into planetary nebulae, and those of young stellar objects evolve into circumstellar disks. That's it for now. Goodbye.